Hello, my name's Erica Donnison, and I'm one of the Alexander Studies Online team. And this month, I have the pleasure of interviewing Tim Cacciatore, who is one of the authors of a recently published paper, which I will read the name of, Central Mechanisms of Muscle Tone Regulation, Implications for Pain and Performance. And this paper is open access, which is always good news. And we will include a link to it at the end of this post. Just going to start by saying hello to Tim. Thank you very much for joining me today. And perhaps, can you start with a bit of background about the paper, who your collaborators are, that kind of.
Sure. Thank you, Erica, and thanks for inviting me on again. This paper was done in collaboration with David Anderson at San Francisco State and Rajal Cohen at University of Idaho, and our publication fees were paid for largely by the FM Alexander Trust, and we're extremely grateful to them. In describing this paper, I often describe my introduction to the technique myself back in the 1990s. And when I was a graduate student, I started reading the literature on the Alexander technique after it helped me with my back pain. And I was a grad student at the time. And when I read the literature, I found this big hole where the Alexander technique should be. And so basically, in short, this paper is the aim of this paper is to help fill that hole. That's the main goal, and it brings a lot of things together to create a framework about postural tone, which is the thing that was missing.
There's a lot of technical terms in the paper. I'd like to pick up on some of them, but if you can just kind of give us a general synopsis of what the paper was about.
So let me just back up slightly. So in a way, muscle tone research has been around for over 100 years, a long time. It was one of the first things that was actually researched. But it went out of favor in the 1980s or so for a number of reasons. But basically because it was hard to do good science on it. It's hard to measure. It's distributed all over the body. It's low level, either passive contributions from, soft tissues and active contributions from muscle activation. It's very hard to distinguish those two. And there are a bunch of misconceptions. So it was a real big mess, and they basically threw it out. And that's where the whole came from, is they threw the idea out basically and settled on kind of an old, what was left was this old reflex model that we'll talk about later. And so there was a paper in 2018 by Viktor Gerfinkel and Yuri Ivanenko. And Victor obviously was a colleague that I worked with a lot through much of this work. And their paper basically, they aimed to establish that tone was different from balance. And the tone was this important thing in need of study. That was one of the major goals of it. There were some others, but what had happened in the absence of tone is that people thought of posture as balance. Right. So if you worked on postural control, what you did is you knocked people over and see how they recovered.
Right.
Right. And that's different. It's a different thing from this kind of steady state ongoing activity that supports you against gravity. They're very different systems.
Mm.
Yeah. And so Victor and Yuri wrote this paper in 2018 that I think brought together a number of things and kind of put tone on the map again, in a very high profile sort of way. But that paper was missing missing a few things. It was missing, well, it was missing the clinical element, like the practical element. Well, why is tone important? It's important. It's hugely important clinically. It's important clinically, well, as we know from Alexander teaches, it helps people with performance. It helps people with pain. Those are the two things that we focused on. So it was sort of missing that element. And it didn't really go into the detailed neurophysiology of the tone system. and it seemed like without that, it was just kind of vague. Yeah. And so by bringing together what was known about it, what's known about it currently, and putting it down in some more concrete way, I think that'll help people understand what's happening. I mean, the final thing that the paper wanted to do that was missing before is that, well, there are all these clinicians. I mean, somatic practitioners, Alexander teachers, Feldenkrais, and there's a range of people who all influence tone in different ways. But I think it's important to acknowledge that there's a lot of expertise out there, and that science should pay attention to that. Uh, um, and I mean, we look up to magicians, we look up to meditators. These are all things that evolve through practical experience and people, learning to do skills, not through the academic science system, right? And science has learned a lot from those things. And the same should be true for somatic methods. Uh,
Uh-huh.
And this audience might be thinking, okay, well, why is he not focusing just on the technique? That's where his research was, and so forth. And I think we're better actually to focus more broadly because for a couple of reasons. Well, one, it'll be more high profile, right? That more people will read it. And two, a lot of the research in the paper or that we describe on the paper on tone from somatic methods is about the Alexander technique. In fact, it's most of it kind of stands out as a model. So we will ultimately reach more people and promote the technique or make people familiar with it, through I think broadening out.
Yeah. Yeah, that's a really good point. I had wondered
Yeah.
that and reading it. Okay, so I just wanted to ask a few more specific questions about
Of
the
course.
paper. One of the things you talk about is the implications for pain, but you talk about the components of muscle tone and how it can and what can affect it and its role in chronic pain. Um, and I was wondering if you could talk sort of more about that and sort of what you talk also about the difference between involuntary and voluntary muscle tone and resting tone
Mhm.
versus postural tone. So things like that. But it'd be really good to hear your kind of explanation of all of that.
Yeah, sure. So I think the first thing to recognize is that tone is different from voluntary activity. Like if you clench your fist, if you make a voluntary movement, um, that is different from tone. And there are a number of different experiments that have demonstrated this. The most recent one, which unfortunately didn't make it into the paper, so I'll describe it because it's kind of fun, and teachers will like this, I think, is a study basically looked at um, which motor units were firing. So, meaning were they the small diameter fibers that innervate red muscle, or the bigger ones that innervate the white fast twitch muscle, or somewhere in between? And you can, through sophisticated techniques, you can sort of differentiate those. And they compared a postural task, so kind of like monkey. They had people do something like monkey, and versus basically lifting a weight, like sitting on a chair and kind of extending their knee voluntarily. And they calibrated the activity so you had the same amount of activity in each case, same amount of muscle activity overall, in the quadricep. I think they're just looking at one muscle, but fine. And well, it turns out different motor units are active for the same amount of muscle activity, right? And this is something that Alexander teachers have been saying for a long time, and actually turns out to be true, happily, is that
Mm.
the red motor units tend to be more active for postural tasks. And we've kind of known that in the literature. It's clear that like soleus, which is deeper from gastroc, is more tonically active, and gastroc tends to be active for movements, where the deep muscles are kind of active more all the time. But we didn't didn't quite understand the mechanism. But it's due to them being activated by different brain systems. Right. So the
Yeah.
postural system is activating different through different pathways, activating the more slow twitch fibers and the cortical voluntary activation through the corticospinal tract is activating the fast twitch fibers. And it's not exclusive, but it's clear that there are different pathways that are involved.
Yeah,
Right.
which
So.
I would think is really interesting in terms of people recovering from a stroke, maybe, or
Mhm.
I've discussed with you before a little bit about motor neuron disease, or ALS as it's called in the US,
Sure.
where it seems that
Mm.
the voluntary system is the one that is mostly affected. That's just from my own work, but there
Yeah.
must you. I'm excited by what you're talking about because I think there's follow on for how we work and how we can help people
Yeah.
who have some of these neurological conditions that maybe this difference in pathways can in some way be be a useful model to work with. And I haven't quite got my head around it yet because I only read your paper the other day, but
Sure.
yeah, I think there's a lot in here. It's exciting.
Yeah. And I should probably say that the paper is meant to be read on different levels, right? It's meant for a number of audiences, and uh, uh, one audience would be Alexander teachers, for instance, right, or people that don't know the science. But at the same time, it's also meant to have the necessary research and the necessary detail in there where it can be read by neurophysiologists and say, oh, this is what he's talking about, and these are the papers, and so forth. And so if you are reading the paper, you can skim over, is it section 5 or something, the neurophysiology section. I mean, it should be readable, but don't worry about the terms and stuff. But I think the paper was meant to be read even if you don't understand a lot of the detailed terminology. Uh,
Yeah, I
um,
certainly found that. There
yeah.
there were bits where I thought, but yeah,
Yes, of
one can
course.
always look them up.
Right. And we could have left those out, but I think then it wouldn't
No,
have the desired effect. Yeah.
yeah, exactly. And actually, yeah, it's a very good point that you want the neurophysiologists and the professionals in that side, the medical side, to be able to understand how we can help, which is or
Yeah.
maybe.
Yeah.
Having
So you
said that,
you asked about properties of tone, though, or
oh yeah,
features of tone. So now we've kind of differentiated the system, and sometimes there's something that confuses people in terms of like postural tone is sometimes used and resting tone is sometimes used. And I mean the difference really is the state of the subject when you measure. If someone's lying down and trying to relax, that's resting tone. And if they're standing up or against supporting themselves against gravity, that's postural tone. Probably a lot of the same circuitry is involved. But that's the difference between those two
oh,
terms.
okay, yeah, well that makes sense.
Yeah.
Um, I do have a couple of the terms that you use that I
Hmm.
quite liked, and I wasn't sure quite what you meant. So one of them is excitability, and how does that affect, or how does that apply in this case?
For a long time, it's been clear if you go back and read some of the old research that excitability, and I'll explain what that is in a minute, but excitability is important to tone, and so it's clear from observations with animal studies where after surgery, there's this fluctuation. There's a surgery that is sometimes done, not anymore, but used to be done really to that exaggerates tone and made it amenable to study. But there would be these periods of fluctuation, and when things were in a sort of high state, it's like there was a lot of tonic activity and the posture reactions were very strong and there's just a lot of vigor, right? And when it was low, the animal would be kind of floppy and not much reaction. So there's kind of this overall state, and you could change that in various ways. You could with people, you can have them, like to a voluntary effort, pull their arms apart really hard, and then there are these tonic effects, or in people with patients with cerebral palsy, if they have some sort of a disruption and you ask them to do a voluntary task with their other hand, or remotely, then that affects the disruption. This is kind of so it's like the voluntary task is upping some state of excitability, which I will explain, that is having these non-local kind of global effects. So what is excitability? So excitability it's basically the propensity of neurons to fire. So and there are neurons all over the place, right? So there's excitability of different populations. It's not a singular thing. But in particular, for certain areas in the spinal cord and in the brainstem, how excitable they are, how much their baseline firing rate is related to how much tone comes out, and also to the adaptability of tone. So we didn't really talk about the other properties of tone. Tone has a distribution. It's adaptive, so that if you lean forward in the chair, your back will tone up, or if a barber turns your head, so some muscles let go and the others kind of take up the slack. So it's adaptive, and that adaptability is increased during periods of higher excitability.
Ah, okay. That makes sense. Um,
Yeah.
and I just wonder what a tonic descending neural drive is.
Yeah, yes, of course.
Possibly look it up.
I'll, of course. So
I just like this
think of
the
the
word.
brain as a loose hierarchy. It's not quite a hierarchy, but it's in part a hierarchy. And the spinal cord is at the bottom, the brain stem's above that, and then the midbrain and the cortex are above that. And so within the spinal cord, you have these feedback circuits, right? That where sensory input comes in and then motor output goes out, that are involved in tone. Uh, um, and it's not just the stretch reflex. It's not the stretch reflex. They're much more complex patterns. So the stretch reflex is a very simple circuit that requires a really high rate of stretch, and it's not tonic at all. That's not involved in tone. If you tap your knee, it doesn't go up and stay there. If you push on it for a long period of time, you're not going to get a tonic knee rise. You won't get a knee jerk. It's something that happens physically. But there are these circuits in the spinal cord that are involved in regulating tone. And it turns out in a certain way they're self-contained to some extent, but if they need signals from the brainstem to function. And you can stop those signals by cooling the spinal cord, for instance, and the signals can't get through, and the animals become floppy, and they become unable to support themselves. But you can then provide some kind of non-specific stimulation, even just pinching the tail, or you can put a small electrical current near the spinal cord from a battery that's doing nothing but just kind of increasing the excitability, and then all of a sudden the circuits start functioning again.
Hmm.
And so what's happening is from the spinal cord, there's this drive that's coming down. This drive meaning an ongoing signal at a certain level, and there's a number of different pathways, and those ongoing signals are kind of creating a state that is switching the spinal circuits on, and it's tuning them to a given context. So it's configuring them, right? It's switching them on and configuring them, so that's what the tonic drive is.
Hmm.
And that's a huge part of tone, right? That's a huge part of probably what we're working with.
Okay. Yeah. Yeah.
Yeah.
I almost wish I hadn't asked, but yeah.
Sorry.
No, no, it's really interesting. Um, okay. Well, in there you did mentioned the reflex, and I really want to ask you about the reflex model of muscle tone, because that's something I've been talking about with my in my teaching for a long time, and I thought,
Yeah.
okay, maybe I wasn't right. Because it does make sense, but what you've just said, it's obviously a lot more complex than that. And so my question is kind of, where did that come from? Why did we think the reflex model? Well, probably because it is more,
Yeah.
but why did we think it was the thing? And yeah, how what do we now think? What do you now think? So
Yeah.
that I'll learn what I should be saying.
Yeah. 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 Yes. So, in order to study tone, there's no, I mean, it's hard to study in people, and it's hard to study in animals as well because it goes away under anesthesia. Anything with an awake behaving animal is difficult to study. The small constant signal underneath, a relatively constant signal, which is tone. Compared to voluntary activity, tone is tiny. It's tiny and it's constant, or relatively constant, right? And so what the early pioneers did, Sherrington, Magnus, and so forth, is they found these surgeries where they actually made a cut in the brain, and the animals basically became very rigid, like boards. The tone went way up. And it turns out there are a number of different kinds, different places you could cut with different properties. This is called decerebration. There are a number of different places that were used that had a number of different properties. The one that was preferred by Sherrington and colleagues was called the intercollicular lesion, and it produced, this particular rigidity that if you then cut the input from the muscle spindles, the animal stop being rigid, right? So it's saying, oh, well, that extra rigidity is solely from the feedback coming in. But it turns out there's lots of different places that you can have damage that result where that's not true. Okay, and so that model would suggest that what Sherrington's model would suggest that it could be a reflex basis, right? Because it's the sensory, you stretch a muscle, and then the stretch goes through the spinal cord and then pulls back and increases the tone, and therefore it's kind of regulating the position. And so that, yeah, so that was the idea. But you can have different damage in a different place that isn't dependent on the sensory input at all. And yeah, so
Just with more understanding and more research about so wider research, I guess, rather than what they were doing, which just made it look simple. There's now,
yes, well, there were debates. If you go back and read those old papers, there were debates at the time. It was complicated. They were a bit hesitant, in generalizing, but it just became accepted,
yeah,
is what happened. And there wasn't the facility to measure the brain areas, that were really necessary, and to measure tone in a way that's comprehensive.
yeah.
Yeah.
Yeah. So, what is the more recent? So I know this is kind of what your paper is about,
Yeah.
but is there a nutshell that you can just sort of,
Yeah.
so exactly
Yeah.
why what we're saying now in effect in this statement?
Yeah. Sure. So there's these different levels, and there's both, I want to say peripheral, meaning sensory contributions, and central contributions. So what in a way, the reflex model leaves out, like, how you could influence tone through your thinking, right? Think your neck free or whatever, right? How is that going to, if there's a reflex that's dictating it, how is that going to work? And so there are these central connections within the brain, and some of those are to a large extent, these descending projections that provide that tonic excitability to the spinal cord. But then there are also sensory input, of course, does shape it, and there are local circuits within the spinal cord. There's circuits that go up to the brainstem, to the cortex, and so forth. So sensory input affects it at multiple levels. But there's also these central mechanisms too, which are the things that have kind of been left out in the discussion, and they're most important to us because we use our intention to alter tone. Yeah, and so those
Yeah.
would be the circuits
Yeah.
that are relevant.
Okay, that's brilliant. That's kind of what I wanted to ask you about the technical side of things, as it were. We're going to do a separate talk for next month, which will pick up on the how I guess this relates to the terms that we use within our Alexander teaching. So thank you, Tim, for now. That was absolutely brilliant. And
Great. Thank you for having me.
the paper there'll be a link to it. And we'll see you next month. Thanks a lot.
Sounds good. Thank you.